Hello, this is Dr. Mears, and today we are going to be learning about using sine, cosine, and tangent in right-angled triangles. Here's some vocabulary. We have theta, which is the angle measurement. For our triangle, here's theta located down in this angle. A is a side adjacent, O is a side opposite, and H is the hypotenuse. Please notice that the hypotenuse is directly opposite or on the opposite, the 90-degree angle. Okay, so we have opposite side and we have adjacent side. So which one, how do we label it? What is the secret? Well, the secret to labeling which one is O and which one is A is to locate the angle first. So here's our theta. So once you locate the angle and side, the opposite side is our opposite side. Then you can say, okay, the other side is going to be the adjacent. Adjacent just means next to. So the adjacent is next to the opposite side. These opposite and adjacent sides are also connected by this right triangle in right-angled triangles. Okay, so let's see what this helps us to do. We have what's called trigonometric ratios. And trigonometric ratios helps us to find values of sides and angles. Or in this case, we're going to be given angles and we will be able to identify the sides. What do I mean? Okay, so remember this is O over H. O represents opposite and H represents hypotenuse. So I'm going to write that in. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. You're going to see me filling this out a lot and writing these down a lot. And so I'm hoping that you'll be able to remember them because you'll be writing them down so much. So why are they called ratios? They're called ratios because we're going to divide an opposite side by the hypotenuse side, and we get the ratio of those sides. So what we're going to do is first look at the 30-degree triangle, or the triangle that has a 30 degrees in it. So this picture right here, that's the only picture we're going to be looking at. You'll notice it has the right angle, it has a 30 degrees, and it has a 60 degrees. So we're going to label our triangle. We know that the side that's going to be opposite the 90 degrees is going to be the hypotenuse, or H. Let's now label our opposite side and our adjacent side. So since we're looking at the 30-degree mark, this is going to be our theta. This is going to be the angle that we're going to be referencing. So across from our angle, this is going to be our opposite. And the only one left is going to be our adjacent. If you're able to set these triangles up and label your opposite, adjacent, and hypotenuse, it's going to be very helpful and you'll get better understanding from it. Okay, so let's find the ratio of these sides. So for our sine of theta, or known as sine of 30 degrees, that's going to equal our opposite, so it's going to be 1 divided by our hypotenuse, 2. So the sine of 30 degrees is 1/2. This will also help us to go backwards. So if we were looking to see what this side measured, this would also say, oh, this side measures 1, and this side, hypotenuse, measures 2. We'll get there soon. But let's just study how to set these ratios up first. All right, how about cosine of 30 degrees? Well, cosine is adjacent over hypotenuse. Adjacent is the square root of 3 over hypotenuse is 2. So that's the square root of 3 over 2. And how about tangent? Tangent of 30 degrees equals, that's going to be our opposite, 1, divided by our adjacent, square root of 3. Now, here's the thing. When we have a square root in the numerator, that's all well and fine. But mathematicians don't like having the square root in the denominator. They want to get it out of the denominator. So correctly writing this, I'm going to teach you a little side note on how to correctly write this without that square root symbol in the denominator. So what this is called is rationalizing the denominator, which means getting this radical symbol out. And what we have to do is we actually have to multiply it by itself. And you're saying, well, Dr. Mears, why do you multiply it by itself? Because remember, getting rid of a square root, we have to square it. And squaring something or a number is multiplying it by itself. And then 1 times the square root of 3 is the square root of 3. So now the square root and the square cross out. We have our square root in the numerator, check, and we have the number 3 because remember, these crossed out, number 3 in the denominator. So simplified correctly, this is the square root of 3 over 3. Okay, let's go to the next triangle, this one right here. So we're done of those. We're looking at the 45-degree angle triangle, 45 degrees and 45 degrees. Now notice, since these two are the same angle measurement, it makes an isosceles triangle. So these two sides are the same angle measurement. So it really doesn't matter which one is opposite and which one's adjacent, but just for practice, I'm going to pick one of them. So I'm going to say that we're just going to reference this angle. And the side across from it is the opposite, which makes this the adjacent. This is the longest side, that's the hypotenuse. Of course, that's always across from the 90-degree angle. Okay, now that we've done that, let's go and find some ratios, everybody. So we're going to do the sine of 45 degrees equals opposite 1 over hypotenuse square root of 2. What are you realizing, everybody? That's right. This square root symbol is in the denominator. I can't have that. So what are we going to have to do? We're going to have to rationalize the denominator. Now, if you're thinking, do we have to do this all the time? Well, if you know 1 over the square root of 3, and then you can just remember that it rationalizes the square root of 3 over 3, then that's fine. We're not going to be doing this rationalizing a lot. I think it's just going to be for these two. So let's go on and do this. All right, so how do we rationalize? We have to multiply the square root of 2 by itself. So what you do to the denominator, you also have to do the numerator. And so when we multiply, 1 times 2 is this, 1 times the square root of 2 is the square root of 2. These are going to cross out because that's actually square root of 2 squared. Those cross out, so I'm left with the square root of 2 over 2. And you probably could see a pattern here with how I'm doing this, what happens when you go from here to here. Square root of 2 over 2. Okay, cosine 45 degrees equals adjacent 1 over square root of 2. And this makes sense because we do have an isosceles triangle. So these two are going to come out to be the same. I love 45-degree triangles. They're pretty cool. Okay, tangent. And I think my lights might be going on. But we're going to get them back on. Okay. And lastly, tangent of 45 degrees. We're going to be getting the opposite, which is 1, over the adjacent, which is 1, and you're right, it simplifies to 1. Okay, and let's do our last triangle, and that's the 60 degrees angle. That's going to be our reference. So we're going to do the sine of 60 degrees equals, so let's come down here. Let's locate 60 degrees. Here's the 60-degree angle. Let's look across. We're going to label that one that's opposite, opposite. Okay. Then the next to it, linked by this 90 degrees, this is adjacent. And then, of course, directly across from 90 degrees is our hypotenuse. So always start with the opposite. That was my secret. Locate the angle, then label our opposite side. Okay. So now that we have it all labeled, sine, opposite, square root of 3, over hypotenuse, 2. Cosine, 60 degrees. Cosine, adjacent, 1 over hypotenuse, 2. Perfect. And tangent of 60 equals opposite, square root of 3 over adjacent, 1, which just equals the square root of 3. Now, why did we do all these? We did all these because you might need to find exact answers. And exact answers are given in fraction form. So square root of 2 over 2 is an exact answer. If we did this out on a calculator, actually, let's do it out on the calculator, and I'm going to show you what happens. So if we did the square root of 2 divided by 2, no, clear. The square root of 2, move over, divided by 2. We don't want the denominator underneath the square root symbol. If we did that, we would get a long decimal. This is an irrational number. It keeps going on. And we don't want that. It's not exact. We don't want that. So in order to get exact answers, you may have to memorize your 30, 60, 90, and 45, 45 degree angles. Are we going to use a calculator as well? Yes. And that's actually going to be during our examples. So keep this sheet. It's a really good reference sheet to go back to. Okay. Examples. We're going to be finding values of theta. So what we're going to be doing is we're going to be finding this, what this angle measurement is. So this is going to be our angle measurement. I'm going to write a couple things down, everybody, though, okay? First thing that I'm going to write down is our sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta equals opposite over adjacent. Oops, adjacent. I like to use my capital A's. Okay. Now, another way to remember this is by using, taking the first letter, I think it's an acronym, am I saying the right word? Taking the first letter, S, and then taking this, OH, okay? And then C, first letter of cosine, and then AH, and then T, and then OA. And what it spells is SOHCAHTOA. And this is one of those, be able to remember strategies that a lot of people know. So just like people might know y equals mx plus b. If you say SOHCAHTOA, they'll be like, oh, I remember SOHCAHTOA from pre-calculus. So it's one of those things that you do get to know well because you're using it so much. So it's just another device to help you remember all of these, because I am not going to be providing you with these on formative or summative if you have me as a teacher. The other thing that I'm going to write up is that we're going to be working in degrees. So what I need you to do on your calculator, let me move this over, is I need you to press mode. So mode is right here, mode right next to the second. And I want you to notice if you go down to the third line, you see radian and you see degree. So I want you to go over so that your blinking box is on degree, and I want you to press enter. Enter. Mine was already on there because I was practicing this before. And then in order to exit out, you just press second mode again. And you notice second mode is this blue quit button. So second mode, and it will just exit you out. So here are the steps to getting it in degrees. So there you go. Okay. So we have a couple things written down and we're ready to go. So number one, find the value of theta. So first we have to locate theta. Then label your sides. This is O, okay? Next to O, linked by that 90 degrees, this is adjacent. So we got opposite, we got adjacent, and yes, this is the hypotenuse. And so I asked myself a couple questions for these types of problems. I ask, what do we have? What do we have? Okay, what do we have? We have a number for the adjacent and a number for the hypotenuse. So I take those two things that we have and I look over here and I say, okay, who has those as well? And hopefully you're seeing that adjacent hypotenuse belong to cosine. And so that's the one that we're going to use. Cosine of theta equals adjacent over hypotenuse because I have these numbers. Then I see, what do we need? Well, we need our angle measurement, so we're going to need this theta. So let's substitute in what we have. Cosine of theta equals adjacent is 4/8. And this is where these trig ratios, the ratios of their sides, help us to find this angle measurement. Now, in order to undo cosine, because we want to solve for theta, we want to get theta by itself. In order to undo this, we're going to take the inverse of cosine. Remember, if you had me before, we learned about inverses. You can watch a video on it. So this is the inverse of cosine. Remember that negative in the exponent spot? And we're going to do that of 4/8. If you want to reduce this to 1/2, you can, that's fine. It's not needed, so. All right, Mears, how do you take the inverse of cosine? Well, if you notice here, let's locate our cosine button. That's our cosine button, but we want the inverse. If you look above it, in blue is cosine to the -1. That's the inverse of cosine. Remember, it's a secondary button, so we have to press the second button and then the cosine button, and you're going to see that -1 pop up. And then you can do 4 divided by 8, or you can do 1/2, that's fine, or 0.5, anything matters. And then press enter, and we get a theta value of 60 degrees. Yay! So this angle measurement right here, this is 60 degrees. That equals 60 degrees. Now, if you didn't have a calculator, let me just show you this. Whoops. If you didn't have a calculator, you would have gotten to cosine theta, and I'm sorry, my brain's thinking faster. You would have gotten to cosine theta equals 1/2. If you had no calculator, because remember, 4/8 is 1/2. So I'm just going to do a little break here to show you that I can get it again. And so you would have taken out your little handy dandy sheet, and you would have said, okay, cosine of theta equals 1/2. Oh, that's right here. So the angle measurement that we're talking about must be 60. So this is how you use our trigonometric ratios to get to an angle measurement. Or we could use our calculator, in which you now know how to do it both ways. 1, using our table, or 2, using our calculator. Okay, let's try another one. Number 2, find the value of x. Okay, so let's go back to our questions. 1, what do we have? Well, we have a side, and we have to find the hypotenuse, but we also have the angle measurement. So this is going to be the angle that we're going to be using. That means we can locate our opposite. So this is our opposite. This is our adjacent. This is going to be our hypotenuse. Okay, so what are we working with here? We have O, and we're looking for H. So we know we have O, and we're looking for H, and you're right, we're going to come up here, and OH is sine. So we're going to be using sine. So I look to see what we have to be able to measure. Well, my lights are going off all the time now. We're going to be looking to see what we have to be able to solve our problem. All right, so let's put our information in. Sine. Angle measurement, 30 degrees, because that's the angle that we're using, equals. Opposite, 10.8, divided by hypotenuse is x. Yay! Okay, let's solve this. Now, the 10.8 and the x are being linked together by division, so let's multiply it to undo it from that side, multiply it over here. So now my x times sine 30 equals 10.8. Let's divide. This is linked by multiplication. Sine 30 degrees divide by sine 30 degrees. Cross that out. X equals, can we take our calculator out? Of course. Let's take it out. Let's put 10.8 divided by. Now this is sine, so you just, whoops, my bad, I'm sorry. This is sine, so all you do is you push the sine. Sine is located right next to cosine, sine. You push in 30 and you press enter, and we get 21.6. x equals 21.6. So the hypotenuse in measurement is 21.6. Yay. You could have changed the sine of 30 to an actual, to 1/2 here. Let's look. This is sine of 30. So in order to do it by hand, everybody, okay, we were here, x equals 10.8 divided by sine of 30. So x equals 10.8 divided by, we know what the sine of 30 is. If we look here, sine, oops, wrong one, my bad. Okay, look here, sine of 30 equals 1/2. So we could have put 1/2 in here, and if you divided that out, you still would have gotten 21.6. So calculator side, by hand, no calculator. Calculator, no calculator. But the no calculator does rely on you knowing this whole entire thing, okay? All right, find the value of the angle K. So this little symbol up here, that means find angle K. So we look at angle K. So we have to find this angle measurement. So we look across. Here's our opposite. Next to our opposite, linked by the 90 degrees, that's our adjacent, and this is our hypotenuse. So I'm really labeling first. So label before you do anything else. So once I label everything, then I can see, what do we have? Okay, we have adjacent and opposite. Okay, who has adjacent and opposite? We see that tangent has adjacent and opposite. So let's write that down. Tangent of theta, O over A. Okay. Let's now, what do we need? We're going to need this. This is the angle that we're looking for. That's what that little symbol means. So we need tangent of theta equals, what's O? 4. What's A? 3. Now, that's just like this cosine right here. You're right. We're going to have to do the inverse of cosine to find that angle measurement. Inverse, -1. There we go. So we bring our calculator over here. We see that we have inverse of tangent. So the tangent button's right here. Above it is its inverse. So we're going to press second tangent, and we're going to put in 4 divided by 3. And you didn't need that extra. 4 divided by 3. There we go. And we're going to get 53.1. So our angle measurement is 53.1. So angle K right here, this measurement, that's 53.1. And let's throw a degrees on there because that's what it is. It's 53.1 degrees. Yay! All right, let's do our last one. If you're getting this pretty good, you might want to just pause it and see if you can do it yourself. Okay, find the value of R. Here's R. Let's see, what do we have? All right, we have this angle measurement. Sweet, so let's label everything. All right, so with the 21 is opposite, adjacent is linked with the 90 degrees, and across that street is our hypotenuse. So right now, what do we have? We have our opposite and we have our hypotenuse. So we need to find our hypotenuse. So opposite and hypotenuse. So we're going to see that's going to be sine. So let's write that down. Sine of theta equals opposite over, equals opposite over hypotenuse. All right, let's put in the information. Sine of 38 degrees equals, we have O, 21 over, we don't have H, R. And that's very similar to the one we did over here. We're going to multiply R by both sides times R. R sine 38 degrees equals 21. Divide by the sine of 38 degrees. I'm losing paper. Divide by sine of 38 degrees. So R is going to equal, we're going to put this in our calculator here, and let's see what it's going to equal. I'm excited. This is the last one. 21 divided by, here's sine, now it's just regular sine, of 38 and 34.1. Notice I'm going to 3 significant figures, 34.1, and this is a side measurement, so do not put degrees on it. It's a side. Like if we had centimeters, we would put centimeters, but none of these came with any type of unit measurement, so just don't put This does not get degrees. That one got a degree right here because it was an angle measurement. All right, so this has been using sine, cosine, tangent in right angle triangles. I hope it helped.